Hello everyone, welcome to one more session of live discussion. Today our topic of discussion is the indoor navigation system. And to talk about this topic, I would like to welcome Mr. Ashwini Kumar Sinha and Mr. Suresh Trivedi. So, my first question is, what are the main components of an indoor navigation system and how do they interact?
Yeah, so the main components of the indoor navigation system, they work in very different ways. Other From the outdoor navigation system, like in outdoor navigation system, our main component is the GPS or the radars. Okay. But mainly we use the GPS one. Okay, but in the indoor navigation system, the GPS didn't work, and they most of the time they fail. So in indoor navigation system, we often rely on the in the on the other different methods like the lidars or radars or BLE based navigation, IMU sensors and all those certain types of things. So the one of the main component is the positioning system that can give you the position, the where you located in that locations inside in the indoor. And these positioning system can either be the BLE based, like using the different kind of different BLE devices and finding the distance between all those BLE devices, the signal distance between all those BLE devices, you will able to get the position. So one is the positioning system, or it can also be the IMU as well. IMU, that is inertial measurement units. Okay, so one is the positioning system, then another is the mapping system. So if in the indoor you need to map the environment so that it will able to positioning will tell you the position, but at what position, what is the environment around you, what are the paths around you. So to find that, there is a mapping system. So mapping system use the map, the floor plans, the walls, the obstacles, different objects inside the rooms, or in the warehouse. Okay, so the second one is the positioning system, second is the mapping system. Positioning system give you the position, the mapping system component give you the mapping. So mapping system generally uses the lidars, radars to map out the environment. Okay, sometimes even the photographic as well, or there are pre-built blueprints maps as well. Okay, then the another component is the navigation system. So in the navigation system, it will navigation algorithm. So navigation algorithm will compute the path, do the path planning and the location and destination. So suppose that I have to go from this room to the next room. So in the path of this in the map, you will see the different obstacle, the balls, the different other, the separation units, the different objects in the room. So it have to find the path along with and avoiding these obstacle of all those things. So then need a navigation algorithm. A particular algorithm is needed to plan out the path and for avoiding obstacle and all this. And then there is the user interface and all these things using which you can control all these, see the whole navigation system. And for the interaction part, the positioning system can interact using the BLE, Wi-Fi, or something. The mapping system can be interact with the, if you are using the lidar, can be interact with that interfacing system. Okay, so these are the things regarding this.
So, how would you approach designing an indoor navigation system for a large hospital?
Actually, designing an indoor navigation system for a large hospital requires a structured and the user-centric approach to ensure accuracy, accessibility, and the ease of the use for the patients, visitors, and the staff. First, consider the requirement analysis. Begin by the understanding the hospital layout, user types, patient, visitors, staff, and the navigation needs. Identify key locations such as OPDs, wards, diagnostic labs, emergency rooms, elevators, and the washrooms. ensure the system supports multiple language and the accessibility features for the elderly and the visually impaired. Next parameter is the technology selection. Since GPS is the unreliable indoors, choose suitable alternatives like Bluetooth Low Energy, normally known as BLE, beacons, Wi-Fi triangulation, or ultra wideband UWB. The accurate indoor positioning. Actually, Bluetooth Low Energy is a cost-effective and widely supported by the smartphones and integrates QR codes or NFC tags at entry points for the quick access. Another parameter which we have to consider is the system design. Develop a detailed digital floor map with the interactive features, build a mobile app and the web interference to the system that can be approached properly. So, real-time navigation, it is very essential. Step by step directions and the estimated time to destination incorporate voice assistant and the search functionality for the user convenience. And the next parameter which we have to consider is the backend integration. Integrate with the hospital's appointment and the patient management system to offer personalized route, for example, from entrance to the specific doctor's room. Add an admin panel for staff to update changes in the layout or the room assignments. Another parameter which we have to consider is testing and the optimization. Conduct field testing to ensure positioning accuracy and the usability across all hospital sections. Continuously collect user feedback and update the system as needed. Last is the maintenance and the scalability. Set up regular recon calibration and the system maintenance. Ensure the designs scalable and to accommodate future hospital expansion or the new department. By combining reliable technologies with the user-friendly interface and the real-time data, a well-designed indoor navigation system can significantly improve hospitals' efficiency, reduce visitor stress, and enhance the overall healthcare experience.
Okay. Okay, so can you compare the centralized and distributed architectures for indoor positioning, and which one would you prefer and why?
Yeah, both are used for the different centralized architecture or distributed architecture. Both have its own pros and own cons, and both have its own area of use. So in the centralized architecture, the everything, the positioning system, the maps storage, the mapping system, the path flood algorithm, everything is centralized and being stored and controlled by one central unit. And in the its pros is that you can update the map softwareically, and you can see the whole mapping system, the path planning algorithm working, and the positioning system, the slammatic system, everything. The slam is the slammatic system that we used in the ROS. You might have seen that. So all these things are being monitored and being controlled from the one central server. Okay, everything data is going to one central server, that is one centralized unit, and it establishes the connectivity between all. Like if you are using the BLE based navigation system, then the whole mapping using the LiDAR or whatever, the everything map is being stored in the server, one central server, and in the same central server, the BLE is getting the position, and based on the BLE position, it is showing your location on that particular map that is stored in the centralized server. Okay, so so that is the part of the centralized server. So these but in these centralized servers, they depends on the network connectivity. You need a network connectivity, and with the low latency, so that your positions and your real-time map and the SLAM or your path planning algorithm all will work simultaneously without any kind of latency. If there is latency, there might be problems like if so they dependent on the consider they depend on the network, and the network need to be very low latency. Okay, and if you go for the distributed architecture like that one, in distributed architecture, most of the positioning system, everything work locally and with the data being stored locally. Like in ROS, you have seen the LiDAR with slammetric position system. Like here, we have the, like if we run the ROS and we use this kind of LiDAR, then this LiDAR will map of the environment, and it will also able to generate the real-time positioning locally on that particular area. Okay, and everything is working locally. There is no transmission of data between them. There is no need to be latency. The LiDAR map itself the environment of the room, and it will position according to the environment based on the LiDAR data in 360-degree. Okay, or if you are using these kind of system, like if you are using the Indus board coin, this coin for the indoor positioning, so you can use the Wi-Fi based different Indus coin out there in the room, and then based on the Wi-Fi signal strength from each of these coin, it will able to position itself. Then here you will get only the position, you not get the map. Then you need a map, so the data need to be decentralized. Okay, you need another map server data that will send it. This device need to be send the position the latitude, longitude, or length and breadth from that particular surrounding, and then that position need to be displayed according to the map saved on the server, and these all these data need to be controlled and sent to the particular server. So both have the own pros and cons. So if you go for the preference, like if your data need to be risky, need to be locally, and you not need a centralized system, is not much necessary, then you can it's better to use this kind of ladder based system where the mapping system and the positioning system, everything work locally. If you want to use the ROS, then you can run the ROS environment locally. Okay, as well. In decentralized system, the data is going to the server. Then you have to maintain the good security system. Your data might not be leaked. Your positioning and the mapping system, everything should be in perfect sync with low latency, so to get the accurate positioning in the real time. Both have its own use. In the warehouse, we use the centralized architecture. And some cases, we also use the distributed architecture.
Okay. Okay. So why is GPS not reliable in indoors, and how can this limitation can be addressed in the system design?
Yeah. So I also want to add a few point on this, and then I will also invite the Suresh if you want to add any more points to my answer. Okay, so the GPS is not reliable in indoor environment because GPS is the global positioning system, or even the similar other similar navigation and positioning system like GPS, what we call the NAV-IC, and different other navigation system, although are not reliable in indoor because they depend on the satellite signals. Okay, they need a multiple number of satellite constellation in the sky to position itself. So how the GPS works? So there are two satellites here in the sky, and here I have the another device here. Here I have the another device. So suppose that these two are the satellites, and here I am. So I am receiving the signal from this satellite. I am receiving the signal from this satellite. So by comparing the signal strength from the both satellite, I will be able to position myself. This is how the GPS works. GPS need to that is how the GPS got fixed. We call it the GPS fix. You might have heard in the while working with the GPS fix. That is what you need, a multiple number of satellite. Only one satellite will not work. You need two number of satellite to position, so that it will able to position itself. That is how the GPS on even the navigation system work. Multiple number of satellite need to be there. Okay. and the more the satellite number, the more accurate will be your positioning should be. Okay, so in GPS system, they as they depend on the satellite, and when you go for the indoor, the satellite signal may not reach inside the room because of the different obstacle around you, like the walls, concretes, and many things. So this satellite signal didn't reach inside the room, so they suffer in the indoor environment. They don't work in the indoor environment well. So you have to go out of the home to get the real time and good signal strength and get good positioning system. So that's why GPS is not reliable for the indoors, and they have the limited address, and they are. And in second more important thing is that in the indoor navigation system, there is a very less amount of space, and you need to be very accurate to the centimeter. I mean, even sometimes millimeter of accuracy. And when the GPS signal, when you come inside the room or indoor environment, in the indoor environment where the satellite signal is very weak, and getting the centimeter level of accuracy in the room is very difficult, because of the if there is a what's the availability of the signal is less, and also the availability of satellite fixing with that GPS chip is less, and or even the nav IC as well. Okay, or similar to the technology. So this technology suffers because of the satellite signal and the centimeter level of accuracy. That's why we need a specialized indoor localization system where you can able to get the map, and also the satellite can't make you the map. Okay, so satellite can give you the data of all the latitude and longitude. Okay, but in the indoor environment, there is one more aspect is that the floors. There are multi-floor building, multi-storage building out there. Okay. So one is the floor, and second thing is the maps of the room. Okay, so satellite can give you the map because it has the camera and the sensor, and the many data will be feed regarding the street to the map. Okay, what we call the Google map. Okay, but in the indoor environment, you don't get the map of the indoor. The Google, those GPS system do not have your indoor localized map. How you have placed the beds, how you have placed the ball inside the room. They need the blueprint of the room, and getting every blueprint of every house is not possible. Okay, and it is also violates the data privacy. Okay, so we need a certain amount, very different little bit of different perspective and little bit of different approach to do the indoor navigation system and indoor positioning system. Okay, so that why the GPS is not reliable for the indoor, either from the map side or from the technology side. Okay, or the accuracy side. So if Suresh sir have also want to add any more points, then he can to that.
Yeah, for that is the reason for the indoor positioning we use the Wi-Fi positioning, because Wi-Fi is the widely available in indoor environment, making it a convenient option. It uses signal strength from the multiple access point to the triangulate a user's advantage. So what is the advantage of using this Wi-Fi positioning? No additional infrastructure needed in the Wi-Fi enabled. And what is the trade-off? Because accuracy is moderate, 3 to 5 meters, and the performance can degrade in signal noisy environment. Another indoor positioning is the Bluetooth low energy BLE beacons. BLE beacons broadcast signal received by the smartphones to determine the location via the proximity or the triangulation. The advantage of the using BLE is the cost effective, energy efficient, and easy to deploy. And what is the trade-off? Trade-off is the accuracy is 1 to 3 meters, depends on the beacons, density, signal interference, and the interference from the walls and the people can affect the performance. Another is the ultra wideband UWB. In this case, actually, UMB is a very short pulses over a wide frequency spectrum for the precise distance measurement, and high accuracy 10 to 30 centimeter, low latency, and the strong resistance to interference. And the higher cost and the requires both infrastructure and the compatible devices, for example, newer smartphone. Another indoor positioning is the inertial measurement unit, IMU. IMU uses accelerometers and gyrometer in mobile device to estimate movement and the orientation. The advantage of using is no infrastructure needed and useful for the short term. Accuracy degrades over the time due to drift and the sensor noise, best when they're combined with the other technology. So we can say that each technology has trade-off between accuracy, cost, power, consumption, and the infrastructure needs. For the best result, hybrid system combined BLE, Wi-Fi, UMB, and the IMU are the often used to balance the accuracy and the coverage in the complex indoor environment like hospital or the malls. That's
Yeah. Okay, so what kind of sensors would you select for a mobile robot navigating indoors?
Yeah. So uh, there are different ways and different sensors can be used for mobile robot navigation system. One of the best sensor and that we all used and it will already being used for widely in most of the robot, like you have seen the indoor robot, indoor cleaning robot. They use the same thing for the ROS waste robot for the indoor environment. All of them use the same thing. Most of them use the same thing, not all of them. Okay, so that is the ladder. This is the ladder. These things ladder. Okay, so what these ladder do? They have the laser waves and they have the receivers, so they can map the environment by moving them, and not only but just mapping the environment in the real time. Okay, they can also able to give you the positioning. That is what called slam, or in the ROS you have seen the Hector slam or cinematic softwares are there. Okay, so they give you the real-time positioning and the mapping both at the same time. They create a real-time map and also position itself in the map. Okay, so that is one of the most common sensor that we use is this one, the lidar one. Another one we use the radars as well, or to map the environment, the 3D radars or many other different radars, wave radars or something like that. Okay. And apart from these, there are few sensors that we used is the IMU sensor, that is the accelerometer, magnetometer. So magnetometer gives you the directional data, at which direction you are. Like this Indusport Coin. This Indusport Coin has inbuilt magnetometer data, and we also need the accelerometer data that give you the acceleration at what speed in which direction it is moving. So magnetometer give you the direction and accelerometer give you the acceleration. So it will be able to position and there is another method called dead reckoning method that is also being used in the GPS, and you can also use it in the indoor navigation system. So by chance you got a big signal strength, or by chance your lidar failed for a few seconds or something due to some region, then you can use the dead reckoning system to plan and navigate itself based on the previous reading. Okay, so like this thing is moving at a speed of 1 kilometer, sorry, 10 meter per second. Okay, in this direction. Okay, so now my radar get get got some this radar got some problem. Then I can use the dead reckoning method, and I can use the previous data that it is moving at the speed of 10 meter per second. So its current position should be according to the current acceleration. I can measure the current position that it should be in this, and if by chance it has moved in a particular direction, then I can use the IMU sensor data that it has moved to this direction at this position. So it would be at this particular position based on the previous position and the speed of this. Okay, so that is what we call the data reckoning. So even when the main navigation system fail, this can give you the real time data. So one is the IMU sensors, the accelerometer, magnetometer, the gyro sensor we use. Another is the lidars. These kind of 3D lidars we use, or sometimes we also use the radar system as well. So these are the main sensor that we use in the indoor navigation system, and we can also use the BLE and Wi-Fi as well. Like this chip has the BLE, sorry, this chip has the Wi-Fi. Okay, So based on the, I can place different Wi-Fi, this similar or different other kind of Wi-Fi devices are there, and this device can connect with all this Wi-Fi and scan this Wi-Fi and get the RSSI, that is the distance between the signal strength. So based on the signal strength, you will be able to get the position, like I have told you earlier. Okay. So we use all of these things, the BLE, the Wi-Fi, the IMU, the LiDARs, the radars for the indoor navigation system. These are the main sensors that we use. Okay.
Okay. Okay. So, how do battery limitations impact your choice of positioning technology for wearable?
Okay. If like I can put it yeah. So for the wearable uh, kind of navigation system, the battery is the impact very well. Like in the, if you are going to use the TOF sensor, lidars or radars, they consume a lot of battery because they are based on the lasers. So uh, if you are going for the, and also they are large size, like this is large size, you can't use for the wearable device. Okay. So, so for using the variable things, or even a small space construct device design for the navigation system, uh, best thing is the BLE. You can use the BLE for that thing. So you can use the BLE beacons based on the, that is, they consume very less amount of energy, and so based on that it can able to navigate. It will give you the position around you. It can give you the, it can act as a position system. So for the battery based where you need less number of battery, where the power consumption is the main concerning about the design, then really one of the good positioning system that you can use for the indoor navigation system.
Actually, may I add something about the
Yes, yes, please.
battery limitation are a critical factor which selecting positioning technology for the wearable device. For example, power consumption of the technology. Uh, when we are talking about the battery limitation, the different positioning technology consumes varying amount of the powers. GPS, while secure outdoor, drain battery.
Suresh sir, Suresh sir, can you please turn on your camera? Your camera is not on.
Yeah, just tell me again.
Can you please turn on your camera?
Sure, sorry. Yeah, actually, when we are talking about the battery limitation, it impacts on the various factors. For example, power consumption of technologies. Actually, different positioning technology consumes varying amount of the power. For example, GPS, while accurate outdoor drain, battery quickly and generally unsuitable for the wearable and the used indoors. Wi-Fi positioning is also relatively power hungry as it requires frequent scanning at the connections to multiple access points. In contrast, Bluetooth low energy BLE is the specifically designed for the low power consumption, making it a preferred choice for the wearable. Ultra wideband UWB, although highly accurate consumption, more power than BLE, and is better suited for the short duration, high precision tasks. In case of the IMU sensors, so inertial measurement units, which include accelerometer and gyrometer, are very energy efficient and the ideal for the continuous short-term tracking. However, they suffer from the cumulative error drift over time and they often need corrections from other sensors like the and next parameter which we have to battery limitation is the duty cycling and the smart sampling. To conserve power, wearable can use duty cycling, switching sensors on and off based on need. For example, the system can activate Wi-Fi positioning only when the significant movement is detected via IMU or when the user enter a new area, smart sampling strategies reduces the frequency of the sensor usage and while maintaining acceptable accuracy. And trade-off between accuracy and the battery life is also important. There's always a trade-off between positioning, accuracy, and the battery consumption. Wearable systems often favor technologies and fusion strategies that the balance reasonability accuracy with the minimum power draw. That's all.
Okay. Okay. So, what challenges arises when scaling an indoor navigation system across multiple buildings?
Yeah, the when you go for the multi-floor or multi-story building, a lot of challenges arises in such type of navigation system, because not only in really in everywhere, okay, in all kind of technology, like if you are using the radars, then they can give you the data regarding the surroundings, not on the multi-floor data. And if you are using the LiDAR, like this kind of LiDAR, it will again give you the surrounding data, the 2D maps, okay, or even the 3D map, but not the multi-floor map. It can't penetrate your floors, okay, or roofs, okay. And if you are using the BLE one, then again the signal from one floor to the another floor, you can't go, okay, it can't penetrate the walls. They suffer a lot of signal loss in the wall. So uh, So in the multi-floor building, navigation system suffers a lot of challenges. And to tackle these challenges, you can exhibit the different kind of tactics, what we call. So by combining different tactics, you can able to handle these challenges. So in the multi-floor building, multi-storage building, like I am currently, it can these lidars or these navigation devices will give you the position that I am at this position in 2D directions. Okay, that I am at this position in the room, but it's the multi-stories room. So you are in this position, but at which floors, at which story, it can't give you that data. Okay, these radars can give you the map of these three, this floor and this floor. But this, while scanning this and getting the position using this, you can only get the this data that you are at this position, not on that particular floor. You can't get that data. Okay. So for getting that data, the floor things, the multi-floor things, one thing you can add is the uh, what's it? The beacons, the repeater beacons. So suppose that you have a one navigation system with multiple of BLE beacons out there, or the Wi-Fi beacons out there, if there was the Wi-Fi technology, then there are multiple Wi-Fi beacons out there that will give you the position on this route. Okay. Then you have repeaters that can repeat the signal or from one in between the floors. Okay. So that one floor, and then you have the mid of the floors, and then the bottom floor. So in between, we have the three different of three to more than three different beacons in between that will transfer the signal from top floor to the bottom floor, and based on the signal strength from the top floor beacons to the bottom to the mid beacon that is between the floor slab and between the bottom floor slab. Okay, in between these slabs, different, suppose there is a multi-floor building, so I have one floor there, so I can attach one beacon here, one beacon here, one beacon in this longitudinal direction. So based on the signal strength of my BLE device, on based on this horizontal signal beacon that I have placed, I can able to get at which floor I am. That is the one thing that you can use. Another is the BME sensor, a BMP sensor, but this sensor didn't work much well in the indoor condition as well. They work more at the higher altitude in the outdoor environment, but you can use BME sensor or BME, sorry, barometric sensors for getting the altitude data. Okay. So using this thing, you can tackle that, but yeah, there is a lot of challenges. These challenges are in the multi-floor buildings.
Okay. Okay. So, how would you handle signal multipaths or interference in indoor environments?
Handling signal multipath in the interference is a major challenge in the indoor environment where walls, furniture, uh, metal objects, and human bodies can reflect or block signals, leading to inaccurate positioning. To address this, several strategies can be applied using signal conditioning and the detection (SCD) techniques. For example, first consider the signal filtering and smoothing. Apply filters such as Kalman filters or particle filters to smooth noisy data and estimate the true position over time. These filters help in reducing the impact of the short-term fluctuations caused by the multipath reflection or sudden signal drops. Another is sensor fusion. Combine multiple data sources such as BLE, Wi-Fi, IMU, and the map constraint. It improves reliability. While BLE or Wi-Fi signals may be noisy due to interference. IMU data, for example, step count, direction, remains unaffected and can provide stable short-term tracking. So, map constraint prevent impossible movement such as walking through the walls. And another is the RSS averaging and the thresholding. Instead of relying on a signal received signal strength indicator RSSI, reading use averaged values over time or multiple VCAR to reduce the effect of the random signal spikes caused by the reflections. Set threshold to ignore unusually strong or weak signals that may result from the interference. Next parameter is the channel hopping and the beacon layout optimization. Deploy beacons using different frequencies and the channels to reduce cross interference. Strategically place beacons to avoid areas with the dense metal structure or signal reflective surfaces and they maintain a clear line of the site where possible. Next is the machine learning based corrections. Train machine learning models to recognize patterns of the interference and the correct location estimates dynamically. These models can learn typically signal distortion in the different parts of the building and the compensate for them in the real time. That's all.
Okay, so what privacy considerations should be taken into account when tracking users indoors?
Yeah, there are lots of privacy consideration when you are using the tracking and users in the indoor environment. Like no one of us want that anyone in outdoor positioning. It's okay that we are in this position, but in the indoor environment, it's our home. It's our private life. So no one want to share it to the other people. So if you are using the decentralized system, like we have told and discussed earlier, that if you are going to use a decentralized system where the every data is going on the central server to locate and to position and to create the map, then there is a lots of privacy concern that might got leaked because our server might got hacked or your, and these are the different privacy considerations that you need to take. And if you are going to use the local servers like decentralized system, that is that where the data is being locally stored, and even in such cases, if you are using the devices like a BLE device, even though you are doing the localization, and you are getting the localization data in locally, if that device has a BLE or Wi-Fi based system, then it can again being the hacked or again be been leaked, that again been leaked. Like sometimes there are several people have concern regarding the smartwatch that we wear. that these smart watches have the BLE device, and this BLE device can able to give you the indoor data, leak your indoor private life data, which floor you are, they can leak this data, and someone can use this data for your for and that you not want to share with others. Okay. So yeah, these are the different privacy concerns. Generally, main privacy concerns happen when you are using the decentralized system. Sorry, when you are using the centralized system where all the data is mapped, all the things goes to the server to control everything and give you the accurate positioning to you. You are sending some data to the cloud or the server, then the privacy concerns are there. Even if you're using the locally, if they are using the if you are using the Wi-Fi or BLE based system, localization system, then that data might got leaked. So there are different privacy concerns that can be happen. So you have to do consider all of these threats, and you have to protect yourself from these different loopholes in the designs.
So, my last question now, what are new technology evaluation going that can help in indoor navigation?
Yeah, so for the indoor navigation system, as it's very challenging and it's different from the GPS, these GPS or Navasi or satellite-based positioning system didn't work in the indoor localization or positioning system. Then there are a lot of scientists and a lot of people are a lot of researchers are doing research, a lot of engineers are doing research in this field to make it more reliable, make it more accurate, and make it more good, so that we can able to harness the indoor navigation system in more better way for the different kind of works like the warehouse management or indoor navigation of the robot, automated robot based catering system or hotels, and lots of area there we are using this kind of technology. Okay. So for the technology evolution, some of the few technology evolution that is happened. One is the MM-based radar-based system that it can give you the data using the MM-based, the radar-based system, and there are few hybrid hardware-free and hybrid positioning system that can use the accelerometer, gyroscope sensor, and the environmental sensor data like the barometer data that I've told you, that BME, BMP 280, something like these that give you the altitude data, and with the mixing with the accelerometer data, gyrometer data, and macrometer data, you can able to do the localization system, the BLE beacons based evolution happening for the indoor navigation system. Then another that Suresh sir have already earlier told you regarding the ultra wide band advancement that UWB, the one that Suresh sir have already told you regarding that. We are now developing these ultra wideband UWB based system, and it is not evolving. So to the centimeter level of accuracy inside the indoor navigation system. And then one of the recent good technology evolved is the 5G technology, or on LP band, that is low power wide band wide area network. Okay, so with the 5G based system, we can use this kind of more accurate navigation system. We integrate more devices with the more low latencies. Okay. Then the argument reality based navigation system, where we can use the real time navigation of our current position into the argument reality, that is the or AR VR thing, what you see in the meta vision and some these kind of things, or Apple vision. Okay. Then computer vision and visual autometry is not evolving, so that these computer vision are able to generate the 3D maps of your environment, of your rooms or indoor things, and give you the 3D maps of the whole buildings, able to create using the computer vision or the autometry. Okay. And then the artificial intelligence and the predictive analytics are now being used in the indoor navigation system, like the path planning algorithms, the obstacle detection, the obstacle avoiding things. We are all these computer vision, the artificial intelligence now being included here to give you the more accurate path, give you the more accurate path planning for the indoor navigation system. And then the high definition maps or slamatic things like these slams, we are developing the radar based system, slamatic things that will scan the environment the real time. Okay, you don't need the pre-mapped environment, you don't need the pre-mapped things. These can give you the create a real time map in the real time and give you the real time position as per the mapped surrounding as well. Okay. So these things are now developing in the field of the indoor navigation system.
Okay. Okay. Anything, Suresh, sir, you want to add to this?
Don't want to add anything else now.
Okay. Okay. So this brings us to the end of this section. I hope this was very interesting and useful for you all. If you have any questions, kindly post it in the comment section. Thank you for your time.
No, thank
Thank you.
you.